This lesson is the area between two curves. Okay, if you recall, in the last section, we found the area bounded by the x-axis in a curve from x is equal to a to x is equal to b. Okay, so today we're going to talk about the area between two curves, not necessarily the x-axis. Okay, so if f of x and g of x and g of x are two continuous functions, and f of x is greater than or equal to g of x for all x on the interval a, b, then this area between the two curves on this interval is it's the integral from a to b, and it's the f of x minus g of x. Okay, dx. And remember, f of x is greater than or equal to g of x, meaning if you look at the graph of these two curves, it's always the top curve minus the bottom curve. Okay, so that's the area definition. Find the area between x is equal to a and x is equal to b between the two curves. Okay, but let me just show you what I'm talking about. Okay. All right. So in the last section, we found that if we look at the integral between x is equal to a and x is equal to b of my function y is equal to f of x, right? If we integrate that, what did we find? We found what? The area from the function to the x-axis, okay? And so now we're going to have another curve, g of x. And what we're interested in is finding this area in between the two curves. So what we would do is find the area from our first curve to the x-axis, right? And then if we integrate from a to b this other curve, g of x, okay, what do we get? If we integrate g of x from a to b, we get this right here, right? So it makes sense to find this area between the two curves. Then we would find this area, the integral from a to b of f of x, and then we would subtract the integral, because if we integrate g of x, we get this area. So we're just going to subtract it off, right? The top curve minus the bottom curve gives us that area, okay? And so we can write that like we did before. That kind of helps it make sense. So to find the area from a to b, if you have a top curve, if y is equal to f of x, and then y is equal to g of x, if you have two curves and you're trying to find the area between the two curves from x is equal to a to x is equal to b, we're just going to integrate from A to B, and we're going to take this top curve, subtract off the bottom curve, and then we'll integrate it and plug in our limits, and we'll find the area. So that's the area between two curves. So the only difference between this section and the last section is the last section we found the area from the function to the x-axis. This time we're trying to find the area between the two curves. Okay, all right, so let's look at an example of that and see what that looks like. Okay, so if I said, let's do this example. Find the area of the region bounded by the curves y is equal to x squared minus 1 y is equal to 1 minus x, x is equal to -1, and x is equal to 1. Okay? All right. So there we go. All right. So how would we do that? So let's just say I'm looking at the graph of these two curves. Okay. So here are my x's. This is the same thing as from -1 to 1. Okay. They're just asking in a different way. So we know if we have two curves, it's going to be the integral from -1 to 1, and it's the top curve minus the bottom curve, always. And I will tell you this, one of these is on top and one of them is on bottom. And if we had a graphing calculator, we could just stick it in our calculator and say, okay, this one's on top and this one's on bottom. But we're not using graphing calculators. But let's just look at the graph of these two functions and then how we could maybe figure this out without looking at the graph. Okay, so if I have, let's look at this, the graph. And here's the parabola, x squared minus 1. Okay. And here's the line of the graph. Okay, so here we go. Y is equal to x squared minus 1. And here's the graph of y is equal to 1 minus x. And we want to know the area between x is equal to -1 and 1. Okay. All right, so if I look at this, and if I want the area bounded between those two curves, if I'm standing in that area, the top curve is the one on my head. That's the top curve. And the bottom curve is the one on my feet. So this would be the bottom curve. Okay, so looking at it, we could go, okay, well, then we're going to just plug that in. It's the top curve, which is 1 minus x, and the bottom curve is x squared minus 1. Okay, well, we're not going to go and learn how to graph all over again. So let's look at these two curves. So y is equal to x squared minus 1, and y is equal to 1 minus x, and our interval is from -1 to 1. Okay, so what we could do is pick any number in that interval. We'll call this y1, we'll call this y2. So what is some number in that interval from -1 to 1? I mean, this is what we're talking about here, from -1 to 1. We want to pick any number in that interval. So I say 0 would be a good number to pick, right? So if we plug 0 into y1, I get -1. If we plug 0 into y2, I get 1 minus 0, which is +1. So look, if x is equal to 0, this graph goes to +1. If x is equal to 0, this graph goes to -1. So what it's telling me is that when you plug some number in that interval, the higher outcome indicates the top function, right? If x is equal to 0, this is 1, that's the top function. If x is equal to 0, This is -1, so that's the bottom function. So you just take some number in that interval, plug it into both of your functions. My outcome is -1 here, +1 here. So the larger value gives me my top function, and the smaller value gives me my bottom function. So that's what we'll do from now on, trying to figure out my top and my bottom function if we can't look at the graph, okay? Pick some number in that interval. So that's what I would have done here. Okay, I would say the easiest number in that interval is 0, right? Plug 0 in for x. 0 minus 1 is -1. 1 minus 0 is 1. So the -1 is smaller, the 1 is larger, so the larger outcome goes on top. So that's what I have. So now we've got it up, set it up, top minus bottom. You have to remember to distribute your negative and combine any like terms. And if you don't put your parentheses, you'll forget to distribute your negative through the whole thing. So don't forget your parentheses. So that's going to be 1 minus x squared plus 1 dx, right? When I distribute minus x squared and plus 1. So I distributed my negative. Now I'm going to combine my terms from -1 to 1. I'm just going to put it in descending order, minus x plus 2 dx. So now I'm where I am, where I was in definite integrals. I've got it already set up. I'm going to find the antiderivative. I'm going to use my basic integration rules. So here I go. I'm going to find the antiderivative. Negative x cubed over 3 minus x squared over 2 plus 2x. I'm going to evaluate it from -1 to 1 and do top minus bottom again. And you'll see this section doesn't take decimals at all. So you have to leave it in an exact form. Okay, so I'm going to do my calculator stuff. All right, so 1 store for x and enter. I'm going to type in my antiderivative, -1 divided by 3 x cubed. And I have to remember to come down. That exponent is blinking up on the exponent, minus 1 divided by 2 x squared plus 2x. Whoops, plus 2x. Enter, and I get 1.66666. I'm going to do my double arrow button right above. Oh, sorry. You can still hear me. I'm going to do the double arrow button there. Right above the, so 1 store for x, I got 1.666. I'm going to do my double arrow button and get 7/6. And then I want to do -1 and store that for x. Enter. I'm going to go up and I'm going to highlight the antiderivative I already have in there. There it is. Enter, enter. I'm going to put my double arrow button to make this be a fraction, which is -13/6. And you know me, I'm so lazy, I go up and I highlight my 7/6 minus my -13/6, and I get 10/3. And that's my answer. That's the area bounded between the two curves. Okay, all right, so we're gonna go on to the homework and just a second and see what we come up with. Okay, so there is just a little bit of something I gotta show you, that sometimes that when we did our first example, we were given our x's. Sometimes you won't be given your x's, but we'll see what happens when that starts. Let's just go and look at our homework. And there are only 4 problems in here, so it's not a whole lot. Let me get this out of the way. All right, so here we go. This is the area between two curves. Is find the area of the region bounded by the graphs. Let's see, y is equal to x squared minus 2. Okay, y is equal to negative x minus 4. X is equal to negative 1 and x is equal to 1. And then we'll always be negative 1 and 1. And then just what's different about this, in the last section, they gave it like this. Okay, it's the same thing. That's the interval. Okay, so we're going to set the integral up when our x's are given from negative 1 to 1, and it's going to be the top curve minus the bottom curve, always. And if you do bottom minus top, then if you do everything right, you'll get a negative answer. And you know that your answer can't be negative because it's area. So then you could just change the sign if you don't want to go through that step. I just like to know what I'm doing. So we're going to pick a number. I'll call this y1 is equal to x squared minus 2, and y2 is equal to negative x minus 4. These are my functions, and this is my interval from negative 1 to 1, right? All right, so if I want to know which is on top and bottom, okay, I pick some number in the interval, and I'm going to pick x is equal to 0 because it's easy to work with, and plug it into y1 and y2. So y1 is x squared minus 2, and y2 is negative x minus 4. So if I plug 0 into the first one, I get negative 2. And if I plug 0 into the second one, I get negative 4. Well, which is larger? That one, negative 2, is closer to 0. Because if you were on a number line, right, negative 3, negative 4, those numbers get smaller, okay? All right, so this is smaller, so this is going to be the bottom function. This is larger, so y1 is going to be the top function. So that's my top and that's my bottom. And like I said, if you do these wrong and do everything else right, you'll get a negative area. So let's go fill those in. All right, so x squared minus 2 is on top. And negative x minus 4 is on bottom. So remember to do your parentheses, and we're going to distribute the negative. So negative 1 to 1, x squared minus 2 plus x plus 4, and we'll combine like terms, x squared plus x plus 2 is my function. And so my antiderivative, we'll use our 6.1 rules, x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 1. So always top minus bottom. So let's see what we get. I'm going to take my 1 and store for x and enter, and plug my antiderivative in there. 1/3 x cubed, 1 divided by 3, x to the third. Come down from that exponent, plus 1/2 x squared, 1 divided by 2, x squared. I use my squared button, you don't have to come down, plus 2x. Enter, and then I push my double arrow button. They don't take decimals in this section. It doesn't say round, so I'm going to do my double arrow button and get 13 over 6. And then I'll do my negative 1, store for x, and enter, and go up and highlight my antiderivative and get negative 13 over 6. And then when I say 13 over 6, I highlight that, enter, minus, go up and highlight the negative 13 over 6 and enter twice, and I get 13 over 3. Okay, and that's the area between the two curves. And it's positive. It was supposed to be positive. If I subtracted wrong, it would be negative. So, so there, negative 1 and 1. Okay, so, all right, so here we go. Let me see, 13 over 3. It says that's the wrong answer. Let me go see what I did wrong. Hang on. Okay, I wrote it down wrong. This was 17 over 6 right here. I must have typed it in wrong. So 17 over 6. And then let's make sure the negative 1, store for x, and enter is right. It's 1 divided by 3, x to the third, plus 1 divided by 2, x squared, and plus 2x. And then I get negative 11 over 6. I don't know what happened to me. So 17 over 6 minus negative 11 over 6, and I get 14 over 3. So 14 over 3 is my answer. And I got jammed up here at the bottom, but that's why I have you turn in your work, you know, because if it's right, it's right. And if you made a arithmetic error on that part, you know, you would get 9 out of 10 points, right, however much it was worth, because you did a whole lot of work right. You just did a little bit of work wrong, but the computer counts everything is wrong. Okay, so that's why I have you upload your work. Okay, so let's look at the next problem. Question number 2. All right, so question number 2 says find the area of the region bounded by okay, so they give us y is equal to x squared plus 3x plus 3, and y is equal to negative x. And that's all they give us. So what did they not give us? We didn't get x is equal to a, x is equal to b, or that interval from a to b. So we have to find x is equal to a and x is equal to b. Okay, so how do we do that? But without graphing it, those are going to be our points of intersection. So we're going to set our functions equal to each other and solve for x. So let's call this y1 and this one y2. We're just going to set y1 is equal to y2 and solve for x. And we got to get 2 of them because we need 2. So x squared plus 3x plus 3 is equal to negative x. Okay, and this is a quadratic equation, and so when I solve for a quadratic equation, I have to have it set equal to 0. So I'm going to add x to both sides, and so I have x squared plus 4x plus 3 is equal to 0, and I have to factor that to find x times x is x squared, 3 times 1 is 3, and they're both positive. So when you full it out, you get 4x in the middle. So you say x plus 3 is 0, x is negative 3, x plus 1 is 0, x is negative 1. So remember, my interval is from negative 3 to negative 1, because here is 0, negative 1, -2, -3. So -3 comes first. So that's my interval. Okay, so now I've got my x's. And this is a smaller one. This is my A, and this is my B. Okay, so I'm going to integrate from -3 to -1, and I'm going to do my top function minus my bottom function. Okay, so how are we going to figure out on this interval which is the top and which is the bottom? We can't pick x is equal to 0 because that's not in that interval. So there's -1, -2 is in that interval, right? So let's let x be -2. Okay, so here are my graphs. So y1 is x squared plus 3x plus 3, and y2 is -x, right? So let's plug in -2 and y2 at -2. Okay, so here I am with me and my calculator. Okay, so I'm plugging -2 in. Y'all see why? Because here's my interval, -3 to -1. Here's 0 over here, 0, -1. There's -2, there's -3. So I'm going to plug -2 in, and I'm going to let my calculator do it. I'm going to say -2, store for x, and enter. I'm going to plug in x squared plus 3x plus 3. And then I get +1. And I'm going to put it into -x and get +2. So +2 is larger, so that's my top. And so that's 1 is smaller, that's my bottom. So y2 is the top function and y1 is the smaller function. So let's go put those in. Okay. So we said the top function is y2, so it's -x. And then y1 is the bottom function, x squared plus 3x plus 3. Okay, so it's a little work to find the endpoints, but okay, remember we have to distribute the negative. So it's going to be the integral from -3 to -1, and that's going to be -x minus x squared minus 3x minus 3. And we're going to combine like terms. So that's the integral from -3 to -1. It's -x squared minus x minus 3x. Shoo! And so that's what I've got. Okay, so that was a lot of work to get where I am. So now I've just got to find the antiderivative by combining doing my 6.1 rules. So -x cubed over 3 minus 4x squared over 2 minus 3x, and I'm going to go from -3 to -1. So it's the top -1 minus the bottom -3. Okay, so -1, store for x and enter. And then I'm going to type in my antiderivative. So I want to be clear that this is your negative down here and this is your minus up here. They're different, okay? So it's -1 divided by 3, x to the third, okay? And minus 2x squared, I'm going to come down, minus 3x. And then I get 4/3 minus negative 3, store for x and enter. And I go up to my antiderivative. And I got 0. Okay, so that would be 4/3. So I'm going to do that again. Negative 3, store for x and enter. Don't always get 0, but that, I'm not saying that you can't. I got 0, so the answer is 4/3. I'm going to put it in to make sure it is right. So 4 divided by 3, and it's right. So that was good. Okay. All right, so we're getting there. It's definitely easier when they give you the x's, right? You'll have one at least with a, you know, with an x, maybe 2, but one without an x. So here we go. Question number 3 is find the area of the region bounded by the graphs of y is equal to x squared, y is equal to negative 3 minus x. Thank goodness, x is equal to negative 2 and x is equal to 0. So yay, that's the interval from negative 2 to 0. Okay, so that's what that looks like, negative 2 to 0. Okay, all right. And so all we have to figure out, negative 2 to 0 is going to be the top function minus the bottom function. Okay, so what number are we going to plug in? Some number in between negative 2 and 0? It's negative 1, right? So I'm going to plug negative 1 into both of my functions. And I'll call this y1 and y2. So y1 at negative 1 is just 1. So negative 1, store for x and enter into x squared is 1. And to minus 3 minus x is negative 2. y2 and negative 1 is negative 2. So you look at the outcomes. This one's larger, so y1 is on top and y2 is on bottom. And it's always top minus bottom. So my top function is y1 is x squared. My bottom function is minus 3 minus x. So I'm going to distribute my negative. X squared, I'm going to put it in order, plus x plus 3. I'm going to find my antiderivative. X cubed over 3 plus x squared over 2 plus 3x from negative 2 to 0. So f of 0 minus f of negative 2. So when you plug in 0 to a polynomial, you get 0. And so I'm going to plug negative 2 in. Negative 2, store for x, enter. And 1 divided by 3, x to the third, come down, plus 1 divided by 2, x squared, plus 3x, and it should be negative 20 over 3, and it's 0 minus a negative 20 over 3, so my answer is 20 over 3, and we knew it would be positive because we found out which was on top and which was on bottom. And so let me put that in my computer, 20 over 3, and boom, that's right. Okay, last one. Here we go. And guess what? They don't give us the x's. This is the last problem for test 2. We got this. Okay, so find the area of the region by the graphs of the equations. Y is x squared minus 12x minus 51. And then y is 3 minus x squared. Okay, All right, so we need to find x is equal to a and x is equal to b, or the interval if you want to write it like that. So we know how to do that. Let's call this y1, let's call this y2, and we're going to set y1 equal to y2 and solve for x. So x squared minus 12x minus 51 is equal to 3 minus x squared. Okay. All right, so since we're solving a quadratic equation, this needs to be equal to 0. So we're going to subtract 3 and add x squared. So that's going to give us 2x squared minus 12x minus 54. Okay, and so we got to factor that. Okay, one thing that would be great is if the coefficient of x squared was 1, it makes it a lot easier, and I see a 2 will come out of everything. So let's take out 2 as the greatest common factor. And what's left over, divide everything by 2. 54 divided by 2, 27. Okay, so good. All right, that makes it a lot easier. And then we're going to factor. So x times x is x squared, and we just have to think of two numbers that multiply to get 27 that also add to get negative 6. So 9 times 3 is 27, but if you add negative 9 and positive 3, they get negative 6. Okay, so you set every factor equal to 0. The 2 doesn't matter because it doesn't have an x in it. So you get x minus 9 equals 0, x is 9, x plus 3 is equal to 0, so you get x is negative 3. Okay, so this is what we've got. That's our interval from negative 3 to 9. Okay, and there's your A and there's your B. Okay, from negative 3 to 9. All right, so that means zeros in there, which is nice when we're going to look for our top and our bottom. Okay, so you ready? I'm going to go to the next page and say the integral from negative 3 to 9, and it's the top curve minus the bottom curve. Okay, and remember, we found the interval, right? It's from negative 3 to 0. Let's go down here and write my negative 3 to 0. So let's plug in 0. What is y1 at 0? It's negative 51. What is y2 at 0? If I plug in 0, 3 minus 0 is 3. So which one is larger? 3 is larger. So y2 is on top and y1 is on the bottom. Okay, I just plugged in a number in that interval, which 0 is always between a negative and a positive. Plugged them into both. 0 minus 0 is negative. 3 minus 0 is positive. The larger outcome gives me the top function. So it's the top, 3 minus x squared, minus the bottom function, x squared minus 12x minus 51. Okay, a lot of space in there. So negative 3 to 9. Let's do 3 minus x squared minus x squared plus 12x plus 51. Remember, we distribute that negative, and then we combine terms. And I'm going to go minus 2x squared plus 12x, and 51 plus 3 is plus 54. Gx. Sure. And now all I have to do is find the antiderivative and plug my numbers in. My antiderivative is negative 2x cubed over 3 plus 12x squared over 2 plus 54x. X, and I evaluate it from -3 to 9. Okay, let's see. Let's do 9, store for X and enter. And plug in my antiderivative, -2 divided by 3, X to the 3rd. Okay, plus 12 halves is going to be plus 6X squared plus 54X. And then I get 486. Okay, I'm going to do -3. -3, store for X and enter. I'm going to go up and highlight my antiderivative and push enter and push enter again. I get -90. So I'm going to go up and grab the 486. There it is, enter, minus, I go up and grab the -90, enter, and I subtract them. I push enter again, and I get 576. And then cross your fingers, 576, enter, and it's right. And so I am done with all of the material for test 2. So your test 2 is Monday, and you have a lot of time to let this sink in and breathe. Don't put it off to last minute. But as always, I can talk to you in the morning. I'll be here at 8, or you've got your work cut out for you. Test 2, practice test 2, quiz 2, everything 2 will be due on Monday. We'll meet here to take the test Monday at 8:30. But in the meantime, I'll be here tomorrow at 8 for questions, and let me know. Okay. All right. Good luck. Okay. I'm going to end the meeting somehow. See y'all.